All right, good morning. Can you hear me? Hello? Okay. Right, thank you. So I will begin now. This extra class, I will cover some of the more basic things lah. Most of the things that I have covered during the class, but maybe in terms of the calculation steps or in terms of some of the things that you had learned before, but then I will not cover in the class. But in this class, I will try to cover in detail when I discuss the question. Uh, I think I will send you this one. I will send you this PDF file after the class in the channel, so you can have a look again if you still don't get it during the class. Okay, let's begin with differentiation. So for this, in order to differentiate this, you can see that this function looks quite complicated in the sense that it has a lot of function inside a function. We have sine. Then we have sine here, but inside the sine we have ln. But inside the ln here is not only the ln x, but ln of x squared. So in this case, we are expect to use a lot of chain rule. Okay, this is the final answer. So let's see how we can actually get this answer by doing it step by step. In order to solve this kind of function inside a function type of function, right? We need to start from the outer layer. Start from outer layer, slowly differentiate it into the inner layer. Not later, layer. Okay, where is the outer layer? This is the outer layer. This is the inner layer. So we start from the outer layer. If we differentiate sine, what do we get? We get 2. We still write the 2 is just a constant, so don't bother about it during the differentiation. So 2 sine, if we differentiate, what do we get? Sine differentiate, we get cosine, cos. And then you write whatever is inside the this sine. In this case, we have this log function. So we are going to write everything inside the log function. Ln of x squared. And then we need to use a chain rule. When we want to use the chain rule, we are moving one layer inside. Now we want to deal with the ln here. So if we differentiate ln, what do we get? Well, from the base is like if we have ln x, if we try to differentiate this with respect to x, then we are supposed to get the x in the denominator, and then we differentiate this x. Differentiate this x, we get 1. Now, in this case, we have ln x squared. So applying the same logic, we can have the x squared in the denominator, and then we differentiate the x squared. If we differentiate the x squared, we are supposed to get 2x, which upon the cancellation of terms, we get 2 over x. So we are going to write 2 over x over here. That's what we get if we try to differentiate the ln and then x squared. Okay, so in the end, we get 4 over x cos of ln x squared. But you notice that the answer here is slightly different from the final answer that we get because of the law of log. So by the law of log, if we have log of, say, A with the power of B, we can take this power out of the log, which gives us B log A. This is the law of log. So in this case, we can write it as 2 log x, which is exactly the final answer that we want. Okay, so for this differentiation question, it is all about the chain rule. I'm not very worried about your product rule and quotient rule because I think that if you remember the formula, it should be fine. Chain rule is a little bit more challenging in the sense that students get confused when the function is wrapped in this way. So before I proceed to the next question, any question regarding this part? If you have no question, you just raise your hand then so that I know I can move on. I need to make sure everybody know how to do the chain rule when you see this kind of wrap function. How about the rest? Okay or not? If not okay, you have to mention it now. Don't be shy if, okay, I assume that everybody is okay with this. And do remember this technique, it can be very useful, not only in the coming tests, you will use it somehow, also maybe in the coming final. So, and this function, this kind of technique of differentiation is quite common. So I hope that you know how to use it. This is just a not so complicated one. Let's say I change it a little bit. Extra question here. I change a little bit. Things get much more complicated. Now, instead of sine, I put sine square. I still have the log x square inside the sine square. Right. Now, for this one, when we differentiate it, we need to be very, very careful with this part, sine square. So when you differentiate this part, we also start from the outer layer. Outer is here, inner is here, right? So we start from the outer layer. When we differentiate sine square, let me write it on another side, sine square like this, just sine square x. If we differentiate it, we get, follow the power rule, we have 2 sine x, meaning that the first step is to use the power rule. Use the power rule, meaning that in the language or in the technique that you are more familiar with is called bring the power down. But we do not change the trigger function. You notice that when we take the 2 down out of the this power of 2 to be multiplied with the sign here, we don't change the sign into cos yet. In fact, let's say the second step is to differentiate the trigger function. Meaning that after we have 2 sine x, then we differentiate sine x. In the end, we get 2 sine x cos x. Now, let me give you another example. What if we want to differentiate, let's say cos to the power of 4 x. Then we use the power rule. We take the power down, 4, reduce the power by 1. So we have cos cube x. Notice that the cos was not changed into sine yet, right? Because later on we need to differentiate the cos. Just the cos itself, not the cos to the power of 3, just the cos itself. And then we get for cos cube x minus sine x. Okay. So understanding this, let us go back to this question. And we have to take the power down, which is 2. So we take the power down, take 2 up, and then multiply with the 2. Reduce the power of sine by 1. Still the ln x squared remains. And then we need to differentiate. Maybe I use another color so as to not confuse you. We need to differentiate the sign. Okay, ln x squared. And then let me write it again using another color. Since we need to deal with this part, which is not just x itself, so we need to use a chain rule. So for the chain rule part, I use red color now. Okay, chain rule. So the chain rule here will give us the same thing that we get earlier, which is 2 over x. You can see 2 over x. This is for the chain rule. The green color is for the higher power trigonometric function. And the blue color is just blue color lah. Nothing important. Nothing really confusing there. So we get 4 sine ln x squared. In the blue color part, we use the power rule, take down the power. And then for the green color part, we get differentiating this, we get cosine. Just write it as cosine. Okay. And then for the red color part, it will be the chain rule. So if I write it, put a remark over here, this is a power rule. You take the power down, that kind of things. And this is to deal with the trigo, deal with the trigo, I would say. And this is the chain rule. Take note that when you the so-called deal with the trigo, you just deal with the trigo. You don't have to chain rule again, meaning that you don't have to chain rule this again. You just change the trigo function. Okay, so that is the more complicated questions. Anyone have any confusion on this part? No question, eh? Okay, fine. Let's move on. So the next thing is, supposingly I need to I want to cover the integration, but I think that integration, even a good student, they may not be able to get it. So and well, I hope that you can actually do your own effort to learn about the integration. If you do not know how to integrate a certain thing, only you PM me so that I can help you. Now, I will focus on another thing, which is the partial derivative. The partial derivatives, this is the essence of the multivariate chapter. And this question comes out from is inside your lecture note. I extracted. Yeah, so to share with you some of the important things that you need to be aware of when you try to find a partial derivative. Let's say we want to find fx, which is to differentiate f partially with respect to the x. Meaning that in this case, we are treating y and z in the function in f as constant. Constant means that just think of them as a number. Think of them as a number. Just like in this case, if we have 2x to the power of a, for example, if we want to differentiate it, how should we do it? A is a constant. Usually how we do it is just think of a as a number. So by using the power rule, we are supposed to bring down the a, right? And then reduce the power of the x by 1. So we simply do this. Although we do not know what is the value of a, we don't actually care. What we care about is we know that a is a constant. We treat it as a number. So in this case, treating y and z in the f as a constant is then very straightforward. So if we want fx, if we look at the first term here, this first term, do we have any x? The answer is yes, we have x, z. So when we want to differentiate this with respect to the x, we just think of the z as a number. So we just need to differentiate the x. If we do that, we get z for the first term. Then minus again, this y here, z here, it doesn't matter. They are just numbers in this case. So we just need to deal with the x over here. If we differentiate it, we get 2x. So 5, 2x, y cubed, z to the power 4. Plus, again, here we have x. So in this case, if we differentiate this, think of this e2x squared y as, say, e2x squared, say, triangle, where the triangle is something that cannot be differentiated. So we will get 2x e2x squared triangle, and then the triangle also need to bring down. I missed that part. In this case, the 2 and the triangle, they are both constants, a number. That's why we treat that as number and we bring it down. So in this case, we have to take this 2x, which we get from differentiating this. And then for the 2 and the y here, the 2 is already here. And for the y, we also need to bring it down, just like the constant, just like the coefficient of the x. Okay. And then we have e2x squared y. This is your fx. Okay. 2 here. No, this 2. This is your fx. So let's try to rewrite it so that it looks better. And x y cubed z to the power 4 plus 4x y e2x squared y. Now, if I want to differentiate it with respect, say, to y, okay, I want fxy. Essentially, this is to take fx, which we get earlier, and differentiate with respect to y. Now we are going to treat x and z in fx as constant. Now, noticing that the first term here, it doesn't consist of any y term. It only has a z term. So if this is a constant, since we already treat the z as a constant in this function, so we are going to make it into 0. If we differentiate a constant, say 2, we get 0. So we get 0 over here. Minus the second term here, we have y inside the term. So we are supposed to not get 0. We supposed to differentiate this y cube. And the rest just rewrite them as they are. Okay. So in this case, if we differentiate, rewriting the rest as they are, and differentiate y cube here, we get 3y squared. Plus, now this is a more complicated one. We have y over here and y over here, meaning that we are supposed to use product rule. So if we are going to use a product rule, let us write it somewhere else. U is equals to 4xy. And then V is equals to E to x squared y. Remember that we are going to differentiate with respect to the y, treating the other as the constant. Then differentiate the u here, we get 4x. Differentiate the v here, we get 2x squared e 2x squared y. Then by the product rule, which is done in such way, the sum of the cross, we have u dv, meaning that 4xy 2x squared e 2x squared y plus v du, or x e 2x squared y. Now, at this stage, you are more or less done. The rest is to simplify it. You only do this, simplifying this, so that, I mean, the more advanced simplification, for example, you want to do factorization or cancellation of terms or whatever, thing like that, do it afterward. For the first stage of simplification, maybe do it later. For factoring, okay, maybe I specified it for factoring, do it later. But for this one, from here, you can actually do a basic kind of simplification. For example, multiply the 4xy into the bracket and get rid of the 0 term. So we have minus 10 multiplied with 3, we have 30. X, y squared, z to the power of 4 plus 4 times 2, 8. X cubed y e 2x squared y plus 4x e 2x squared y. This is rather the good one. Of course, you can further simplify it by factoring the exponential term, but at this point, you should do it later if it is needed. If not needed, the question doesn't actually force you to write in a specific form, then I advise you to stop here. It's good enough. So that is a partial derivatives. Any question? You can try for the the others, right? If you have the time. Why does z become 0? Shouldn't it be a constant? Okay, so let's say in this case, the z, you notice here, this z is in the fx, and we are supposed to take this z as a constant, right? Supposingly, if it is a constant, as I mentioned earlier, if we have to differentiate a constant, let me write it, constant, we get 0, meaning that, let me give you some examples, like the one over here. Differentiate 2. 2 is a constant, right? It's a number. It's not a variable. It's not x, y, z. It's not a variable, so we get 0. Let's say we have another constant. Let's say 4. We get 0. We have another constant. Let's say this case we have AB. A and B, they are both numbers. You still get 0. So in this case, if we differentiate the z, which is supposed to be a constant, then of course we get 0. Understand now? Okay, good. So this is the very important part of partial derivatives, which encompasses the whole chapter 3. You need to really understand this, to master this part, treating what as a constant. And I think the differentiation part is just something that is considered easy when you have a bit more familiar with the differentiation from chapter 2. Meaning that if you can handle this, like 2 sine ln x squared, if you can handle this, and you know the product rule and quotient rule, you should be able to do this partial derivatives very well, provided that you keep this treating something as constant in mind. Then everything should be fine. Okay, that is partial derivatives. Now with your skill in partial derivatives, let's move on to this kind of question. So this kind of question is a very popular question. It's not popular per se, it's more on a question that can test everything that you understand. Not everything, majority of the things that you understand from this multivariate chapter. Meaning that if you can answer this question, you more or less have done the majority part of the important things in this chapter. So we have a function here. First, part A1 is to find the first order partial derivatives. So let's do that. A1, first order. When the question asks you for first order, you need to find how many variables are there inside the function. We have 1, 2, 3. We have 3 variables. Meaning that if you want the first order, we are asked to actually find fx, fy, fz. So in this case, let's begin with fx. Fx here, noticing that both of the terms under this f function as x, and we are going to treat the z and the y as a constant. So in this case, let us just write down what are the constant. We write them down. Okay, and then we differentiate the x. If we differentiate the x, what do we get? Get 1. Plus, write down the constant and differentiate the x squared, we get 2x. Rewriting this, we get sine z plus 2xy. Then for the y, we notice that the first term doesn't have any y. So we can conveniently write it as 0. But maybe to further reduce your confusion, let me just follow strictly what I have suggested earlier. Write the constant first, and then differentiate with respect to y for this term. But this here, there is no y. When there is no y, right, we can write 0. Then 0 multiplied with anything, we get 0. Then the second term we have y. So we write the constant, which is x squared, and then differentiate the y here, we get 1 equals to 0, 0 we don't write, x squared. Then finally we have f of z, which is the first term we have the z. So we write the x first, differentiate sine z. Here we get cos z. We don't have to do any chain rule here because there is nothing to chain. Inside the sine, we only have the z, which is to a power of 1, nothing to chain that. Plus, the second term, we do not have any z, so we multiply with 0 for the constant. So it's finally we get x cos z. Okay, that covers the first order partial derivatives. Then for the second part, we are asked to find the gradient. Gradient, supposedly this is, to be complete, it should be gradient vector. Okay, usually we will mention gradient vector, or we will give you this triangle. Then you know that you are looking for the gradient vector. Gradient vector is the one of the most important thing that you should learn, you should know for this chapter. So let's see how we can calculate it. Regarding the concept or idea of gradient vector, I think that for you it's not necessary to know. So let's begin with the how to actually find the gradient vector. The gradient vector is, if I write as a formula, is fxi plus fyj plus fzk. If I write in the pointy bracket format for the vector, it is like this: fx, fy, fz. Remember that this is a gradient vector, so your answer must be a vector. It must be a vector. It's not a number, an expression of x, y, z, not like that. It must consist of a vector element in there, meaning that the I, the J, the K, or the pointy bracket to indicate that this is a vector. Okay, let's just say we go with the IJK one, which is much clearer. What you need to do is you just substitute the partial derivative, the first order one that you got earlier, into the formula here. So what you need to do is, for the fx, we have sine z plus 2xy I plus fy is x squared j plus the fz is x cos z k. Done. That's it. So if the question never asks you, like in part A, asks you to find the partial derivative, it's okay. You proceed to find the partial derivative first order one as well, because if the question asks you for gradient vector, eventually you still need them, right? That's why I keep on repeating in the class. For this chapter, if you see a function which is multivariate, and you suddenly, for whatever reason, you just do not know how to start, I recommend you to start by finding the first order partial derivative. It somehow will be related or included in the answer, most of the answer, okay? Of course, it will be better if you know the complete steps. Now, the part 3 here is to substitute values. We need to find the gradient vector when the x is 1, y is 2, and z is 0. So this is here x, y, z. Someone asked a question. A first order, okay, right. Let me go back. First order. Now, what is first order, second order? In differentiation, it simply means differentiate how many times? Differentiate one time and differentiate two times. Let me give you one very straightforward example. Very straightforward kind of example. Let's say we have a function which is f(x). Okay. Now that's single variable. It is equals to 2x squared. Now, if I want the first order, I differentiate it once. I differentiate this function once, is essentially it means that I want to differentiate 2x squared. So I get 4x. Now, this is the first order. I will say df dx, or sometimes we write it as f prime. I'm talking about single variate here. I will show you the multivariate later on. Now, if I want the second order, then I need to differentiate it another time. So I have double prime here. Second time. Essentially, it means that I am taking the f prime and differentiate it, which means that I'm taking 4x and differentiate it. I get 4. That is second order. First order, second order. Now, let us extend it to this case. The question asks for the first order. So we only need to differentiate it once with respect to x, y, z, because this is a partial derivatives, a multivariate. Is that clear now? Okay, very good. How about the others? Are you clear with what is first order and second order? Okay, very good, very good. Right, so let us continue with the simple sub-question of substituting value. Do take note that it is standardized, not actually standardized. Let us look at the function. It can be tricky sometimes. I didn't share it during the class, but I should have, but I assume that most of our students know this. If I write the function in this way, then the first one must be x, the second one must be y, the third one must be z, right? Although in the class I said usually we follow the standard where the first one is x, the second one is y, the third one is z. But not always like this. Let's say I want to be a little bit deceiving or tricky. Just try to confuse you. I will say my function look like this. Suddenly, I don't follow the standard anymore. I don't x, y, z. I put x, z, y. Then I ask you to find the gradient vector. Still the same. You still get the same thing. So nothing changed when you write it in expression like this. Nothing changed. Okay. So but then when it comes to this part, 1, 2, 0, then it's not standardized anymore. This is x equals to 1. Now your y is equals to 0 because you see how it's linked, respond to, and the z is equals to 2. But then in this case, since we are dealing with this x, y, z, so we know that the x equals to 1, y equals to 2, z equals to 0. I'll do a quick check just to see if I'm trying to play a trick like this in the question. But usually we don't play this kind of tricks, okay? Just to remind you, maybe later on, somebody like to play this kind of trick, you know. So what you need to do is you simply need to substitute these values into your gradient vector that you have found in the second part. So z is 0, so sine 0. X, y is 1 and 2. Then you have your I. Then plus, maybe I write it in another row, but no need. Just 1 square j plus 1 multiply with cos 0. Okay. Then you do your calculation. You do your calculation. Now take note that sine 0 is 0. This is 2 times 2 equals to 4 for I plus j plus k. This is the gradient vector when you substitute these x, y, z values into the expression. Now, something to take note that please remark here. Make sure your calculator in the radian mode. In for calculus type of. Okay, meaning that in vector use, if you still remember, there are some questions ask you to find the angle, right? For that angle, you should use a degree mode. How many degree? 60 degree, 32 degree, like that. But for calculus, most of the time, the number that are substituted into the trigonometric function, they are in radian one. So you need to make sure that your calculator is in the radian mode when you do the calculation for the, say, differentiation integrations calculation. Understand what I mean? The mode of the calculator. When you are dealing with calculus, remember to switch it to the radian mode, or else the answer that you get will be much smaller or just very off. Okay. Now we are done with the first three, which is pretty straightforward. The last one is the directional derivative. The directional derivative is, again, not something that is very complicated. You just need to know two things. You need to have a vector. You need to find for the vector. If you read the question, we are asked to find the directional derivative. Then, if you see that there is a directional derivative, no matter how or where, you need to find the vector. A lot of time, the vector is given, but for some very complicated kind of questions, the vector is not given, but need to be found. So in those kind of questions, if you cannot get the correct vector, it's all right. You can invent or put in some wrong number vectors, values vector, and use that just so that you can proceed to show me that you know how to calculate the or find the directional derivative. Do not leave blank because you do not get the needed information to answer a certain question. Sometimes using the wrong answer number, but correct steps will help you with a little bit in your scores. So getting back here, the vector is given, fortunately. So this is a very straightforward question. So to do that, the first thing that you should do is to find the unit vector. Unit vector of this vector, okay? So finding the unit vector, as a reminder here, let's say the vector given in the question is v, so we stick with the v. We find the unit vector. If you forgot the symbol, is okay. You write the name unit vector like this. You just write the name unit vector. If you forgot that unit vector is supposed to be a letter with a pointy cap like that, is fine. You write the unit vector of v. It's also okay. And then the unit vector is supposed to take the vector divided by the magnitude of the vector. So the vector itself, for calculation, I don't like to write IJK. I prefer to use the pointy one. So the vector given is 2, -2, and 1. So I write 2, -2, 1. Then how to find the magnitude? It is simply taking the square root of the 2 square plus the -2 square plus 1. So you just take the number from the top, bring it down inside the square root, square it, and plus with the rest. That's how you find the gradient, the magnitude. So in the end, you get 1/3. 1/3 coming from the square root. Inside here we have 9, so square root of 9 is 1/3. Yeah. Say I want it to be very detailed, so let me give you the very detailed version. Square root of 9, which is 1/3, 2 -2, 1. Now, do you need to actually multiply the 1/3 inside here? The answer is not necessary. Maybe not at this stage. In fact, if you leave your answer in this, is fine. If you leave your final answer of the vector in this form, is fine. But that is not the final answer yet. We have more things to do. The directional derivative of the function f be here written in such way. I forgot. Let me refer back. Directional. Okay. dv f. Okay. Equals to taking the gradient vector of f. Since the question, if we go back to the question, mentioned that specifically at 1, 2, 0, which is essentially the same as here. So 1, 2, 0. So we are taking the gradient vector at 1, 2, 0, and then dot product with the unit vector. This is the formula. This is the formula that you definitely need to remember if the question asks for directional derivatives. So I put a remark here. Remember, we already have the 4 plus 1, 4i plus j plus k from the previous part, right? So for calculation, again, I prefer not to use the IJK version. I prefer to use a pointy one. Much more easier for me to see. Dot with 1/3, 2 -2, 1. Now let me do it the step-by-step way. 4, 1, 1. Now I multiplied it into the vector. I get 2/3 minus 2/3, 1/3. Now for the dot product is to take the first, multiply with the first, plus take the second, multiply with the second one, plus take the third one, multiply with the third one. That's it. That is dot product. In the end, you get 7/3. That is your directional derivative at that point with a given vector. Any questions so far? Any part that are not clear? It's a good time to ask now. This is private chat channel. Everybody on the same boat, trying to get better, trying to pass this subject. Any question? Okay, no question. Very good. So for this part A, I really hope that you can answer this. Able to do this question is very important to at least know that you actually can answer questions from this chapter. Now, how about part B? Part B, maybe I use another R. In what directions does the F change most rapidly at this specific point? And what are the rates of change in this direction? Well, for this kind of question, maybe it will be better to just memorize it on how we actually do it. Let me write some steps for that. First of all is the first thing that you need is your gradient vector. Second thing, calculate the magnitude of the gradient vector. Third, statement. You write a statement. So let's begin from the first part. Find the gradient vector. I think what we already found the gradient vector, right? The gradient vector is for from the previous part. Let's go back. Gradient vector at this point is 4, 1, 1. So we write it over here. 4, 1, 1. Second part, find the magnitude of the gradient vector. Now, don't be confused by the word gradient vector itself. Gradient vector, deep down, it is still a vector. The base is still a vector. So finding the gradient vector, the magnitude is taking the square root. Take the 4, square it, plus the 1, square it, plus another 1, square it. That's it. You get square root of 18. It is all right if you don't write this as, say, decimal. And it is also all right if you want to write it as a, say, decimals. Now, the third one is to write the statement, which I need more space and highlight it in red color. Now, the third part, it only mentions change most rapidly. It doesn't mention max or mean. It doesn't mention, right? If it does not mention, then you need to write both. If it mentions the maximum rate of change, or increase most rapidly, decrease most rapidly, then increase means that it is max. Decrease means that it is mean. Since this case, we doesn't have increase or decrease, it only mentioned most rapidly. We know that it is somehow this kind of question of maximum a rate of change, maximum or minimum rate of change. So we need to write the statement. How to write the statement in the case of max or the case of increase.
这个我们两个人有什么？哎，是啊，只有
All right, for the max and increase case, we take F
有可能是那个加鸡蛋的那个水
increases
一加鸡跟香蕉
most rapidly at P, meaning the point 1, 2, 1, 0, 1, 2, 0, at this point P, 1, 2, 0, in the direction of the gradient vector, the maximum rate of change is square root of 18. You see, a plus square root of 18 must be positive. So the important keywords here are increase. And of course, you need to have the point if it's given, direction of what this gradient vector, and the max or mean rate of change is this one. So it follows a certain standard of writing this statement. You just need to somehow memorize it. I think that is a part that wastes most of your not waste, that you need most of the for this kind of question. This is a part where you need to memorize the most lah. Say, right? How about the mean and the decrease? So we can write, just reverse it. Increase, we change it to decrease. Most rapidly at the same point in the direction of, now instead of this, we need to change the sign. Let's change the sign. As you can see here, from plus, now we have minus. Okay, and the max now is mean, minimum rate of change is minus square root of 18. You see everything reverse, decrease, minus, asset, and mean. These are the changes when you have different cases. So read the question carefully, and you will know whether you will need to write the max statement or the mean statement. Right. Before I move on to the last thing that I want to discuss to enhance your understanding in anything regarding this question, this part B, the maximum or minimum rate of change. Don't be too creative. Don't think about the logic there. Just for your, if you are in a rush, or you just want to pass this subject, I recommend you to understand how to do now, and only later on you wonder why we write like this. The steps are given as discussed now. Any question? No question, huh? Okay. Now moving on. Please take note. Please take note. Practice on this question. Practice. Okay. Keep on doing this. Maybe if you want, you can change. You want to challenge yourself, you can change this function to other functions, change it to other functions, and work on the same type of question, just to familiarize yourself with the type of questions. If you can answer all these parts, right, you already like master half of the this multivariate chapter. Okay. Next is the unconstrained optimization with what I call the D. I call it a D test. I don't think you get anything like D test online. D test, because we use a formula which is called the D formula. The D formula is simply fxx, fyy minus fxy whole thing squared. That's the formula. That's it. That's what you have. Okay. Find the critical points of this function that looks rather complicated, but in fact it's just a long expression of polynomials, which is easy to differentiate if you ask me. Indicate whether each such point gives a local max, local mean, a local max, or saddle point. The first step is step one. Step one is to find the first the partial derivatives. Usually the function that usually not all the time, the function that will ask to find the critical points only consists of two independent variables, x and y. maybe we the question don't use x and y, m and n, p and q is fine, as long as you know how many independent variables are there, it is good enough. So to find the partial derivatives, we need to find all the first order. So first order, we have fx. So if you have enough practice, you can do it actually very, very fast. You just use your eye to see. You get 3x squared. Treating the y squared as a constant. So we have 3, differentiate the x, we get 1, 3y squared minus 6x. Doesn't have any x, doesn't have any x. No x, no x, right? So if no x, just 0. Don't write anything. Fy. Now we treat the x as a constant. First term, no y, so 0. Second term, differentiate y squared, we get 2y. 2y multiplied with 3x, we get 6xy. And then third one, the next one, 3x squared doesn't have any y, so 0. 3y squared, differentiate, we get 6y, so minus 6y. And the last term is number 4, so doesn't have any y, we get 0. So this is the first order. Then you also need the second order. Maybe second order. So for second order, you need fxx. Refer to the formula here. Xx, yy, xy. So we need 3 of them. So you try to find fxx, taking the fx here. You differentiate with respect to x. I write this. The differentiate with respect to x now. You get 6x. The second term doesn't have any x, 0. Third one, we have 6x. Differentiate it, we get 6. Fyy. Since it's yy, right? We are taking the y differentiate with respect to y. So 6x minus 6. Again, same thing. Then the last thing is taking the fx, differentiate with respect to y. So maybe I write it over here, a remark, just to remind you what is happening. This here to take find differentiate, okay, differentiate fx with respect to y. Partially lah. So meaning that we are going to take the fx here, and then instead of differentiate with x, we differentiate with y. So first term we don't have any y, so 0. Second term we have a y squared. If we differentiate y squared, we get 2y. 2y multiply with 3, we get 6y. Third one, we don't have any y, so just 0. That is our fxy. So here, second step is to find the critical point. For the critical point, I advise you to start by writing the fx, which is 3x squared plus 3y squared minus 6x. You let it to be 0. Fy equals to 6xy minus 6y equals to 0. Whether you know how to solve this, don't know how to solve this, you write these two first. These two, write them out, you get something, right? Because it shows that you at least know what is the first step of getting the critical point. Okay, the rest is to solve simultaneous equation. Solve simultaneous equation. And this is the part which is truly not included in the syllabus. There is no subsection or extra note about how to solve simultaneous equation. And I believe that, truly believe that, before you enter the university, you already know or taught how to solve simultaneous equation. And you just need to recall how to do it. Let me do it quickly. 6xy minus 6y. I begin from here. I factor out the 6y. I have x minus non-zero. 1 equals to 0. So I have 6y equals to 0. X minus 1 equals to 0. Here I get y equals to 0. And here I get x equals to 1. Now I have y equals to 0 and x equals to 1. The next thing is I want to know what are the corresponding x for this y equals to 0 and what is the corresponding y for this x equals to 1. So I substitute subs y equals to 0 into fx. Okay, this is the first one, not fx, into the first equation. Let me write it first, second equation into 1. So I substitute it into 1, I get 3x squared minus 6x equals to 0. Remember, do not cancel term when solving simultaneous equation. Do not cancel terms when solving simultaneous equation. Do not ever do that. For example, you take 3x squared equals to 6x, and then you cancel it off. No, don't do that. Don't cancel terms like this, especially, maybe I don't use the terms, variables. I should, variables. You don't cancel the x. You can cancel the 3 and 6, but never the x. Okay, so here, 3x. So we have x minus 2. Then we get two values, right? 3x equals to 0. So x equals to 0. X minus 2 equals to 0. X equals to 2. So when y is equals to 0, we have x equals to 0 and x equals to 2. We can form the pairs like 0, 0 for this, and 2 and 0 for this, right? Then we repeat for the subs. X equals to 1 into 1. So we have 3, 1 square. So I don't write anymore. 3, 1 square plus 3y square minus 6 equals to 0. So we have 3y square equals to 3. So we have y square equals to 1. This will give us y equals to 1, y equals to minus 1. So we know that the pairs are 1, 1, and 1 minus 1. So how many critical points do we actually have? Let me highlight them. This, 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 and this. They are all legit. So we have 4 critical points. Then come to the part where you need to use the D formula. Now, before I continue, any question regarding this? If let's say you do not know how to, or not able to solve the simultaneous equation, what are the options that you have? You just try your best. Even though you don't get a correct value like 1, 1, 1 minus 1, 2, 0, 0, 0 like that, you still give some critical points because you want to try to earn some marks from the next section of the solution. The next section of the solution is the D test. Remember the D here? So the D formula for the third one, okay? I call it the test, the D test. The second one is to find the critical points, right? Third one is not the D test. What you need to do is for each critical point, let's begin with 0, 0, 1, 1. Let's begin with this critical point. For this 1, 1, what we can do is you take the fxx, substitute 1, 1 into it. You substitute 1, 1 into here, minus. Let me go back here and copy the whole thing here and put it over. That is it. I make it super small. Put it over this side. Okay, referring to this one, we just need a second order actually. So on the whole thing, I just give you the second order. Yeah, it's it here. Now refer to this second order that you get earlier. What is your xx? 6x minus 6. So what you need to do is simply substitute them. Your d is equals to fxx is 6, 1 minus 6. That is your xx. Yy, again, same thing. Xy. Then you get minus 6, sorry, this one should be square. You get minus 36, which is less than 0. So, saddle point. When your D is less than 0, it must be a saddle point. If it is more than 0, then we do something else. So the important thing here is you calculate the D. You get the value and you draw you see whether it is less than 0 or more than 0 or equals to 0. All of them will draw to some certain conclusion which refer to the lecture notes. The conclusions are given on the beginning part of the theorem, the D formula there. If it's less than 0, then you draw a conclusion which you say set the point. Done. Easy 2 marks over here. Let's try another point, 0, 0. Again, using the same formula, 6, 0, minus 6, multiply with 6, 0, minus 6, minus 6, 0, square. So what do we get from here? We get minus 6. Is it? Minus 6 minus... No, we get 36. A bit blur here, 36. Minus 6 multiplied with minus 6, we get 36. More than 0. When it is more than 0, be careful, you need to... It is either max or min. So the next thing you need to find is what is your fxx when it is 0, 0. It is 6, 0 minus 6. We get minus 6, which is less than 0. And then you can draw a conclusion. So local max. Now you see here, D formula calculate. You get more than 0. Then you cannot draw a conclusion yet. Then you check your fxx. You find that it's less than 0. So local max. And the last point is 2, 0. The last point is 2, 0. D formula here is substitute 2. And then and as well as a 0 into there. So we get again 36, which is more than 0. When it is more than 0, the next step is to find the f(x)(x). But this time around, when we do the substitution, we find that 2 minus 6 is 6, which is more than 0. When it is more than 0, so local mean. You see here, calculate the d, get more than 0. Calculate the f(x)(x), get more than 0, local mean. So this example itself already show you the possibility of getting saddle point, local max, or local mean. Also, it has quite a challenging solving simultaneous equation. So I would say this question is a very good practice for you to actually master this kind of unconstrained optimization. All right, so the last question here, they are actually coming from the tutorial. So for coming from the tutorial, I don't think you are given the answer anywhere. Let me see. Yeah, actually you are given the answer. You are given the answer. So maybe let me do quickly for one of them. Question. Okay. I'll do the third one. The first one you can practice it yourself. Huh? If it's discussed already in the tutorial, maybe you revisit it. The third one. Let me do it real quick. First step is the partial derivatives. So to find the partial derivatives, we find the first order. Because the first term and the third term consists of x, the second term doesn't, so we just ignore the second term or make it 0. Fy, we have, I'm looking at the third one, sorry. Fx is 3x squared minus 2y. And then Fy is minus 3y squared minus 2x. Then I want to find the xx. I take the x and then differentiate with respect to x again. I take the y and differentiate with respect to y again. And then finally, I also need the xy. Take the x, differentiate with y, get minus 2. Before I continue, any questions regarding the PD? All good? All right, all good. Now, second part, critical point. The most challenging part, as usual, we start by writing the fx to be 0 and fy to be 0. Again, this is the part where you need to do the solve simultaneous equation. So let me begin with, say, the first equation. 3x squared minus 2y equals to 0. So I know that 3x squared equals to 2y. So y equals to 3 over 2x squared. So this is the relation that I get, which doesn't help me to answer anything yet. So I substitute the y equals to 3 over 2x squared into 2 and hope that something can happen. So I have minus 3 over 2x squared minus 2x equals to 0. So I have minus 27 over 4x to the power of 4 minus 2x. Again, do not cancel the so-called the variables. during solving the simultaneous equation. You can factor them out, but never cancel. So let's just take it conveniently, x out of that. Minus 27 over 4x cubed minus 2. So one of my x is equals to 0. Another of my x is rather ugly, but doable. Minus 27 over 4x cubed equals to 2. So x cubed equals to minus 8 over 27. If you use your calculator, you get minus 2 over 3. Just so happen that it is a nice fraction. Okay. Then we take this and this, put it back into here. I use another color. This and this, plug it back into here so that I can get the corresponding y values. So when x equals to 0, my y is my y is 0. When my x is minus 2 over 3, I get my y to be 2 over 3. Then I have my critical points, 0, 0, minus 2 over 3, 2 over 3. These are my critical points. Then I proceed. For the third step is to do the d-test. For the d-test, I recommend you whenever you see unconstrained one, to remind yourself the correct d formula, you just quickly write it out somewhere on your exam question paper or in your answer script, write it somewhere. Just so that you remember the formula and you know that you need to use this formula to do the test. So you write it somewhere. And then since we have two critical points, let's begin with 0, 0. And 0, 0, D is our x, y, y, x, y. Let's take it from here. Take it from here, and then you see x is 6, 0. Multiply with minus 6, 0. Minus 2 square. Okay, and we get 0, 0, minus 4. So minus 4 obviously less than 0, so set a point. On the other hand, if minus 2 over 3 and 2 over 3, our d is 6 minus 2 over 3. Multiply with minus 2 over 3 minus the where fxy is minus 2 square. Well, if you calculate it, which is a little bit more tedious, you get 12 more than 0. And more than 0, what should we do? Fxx. So we have 6 minus 2 over 3, which is a negative value. Minus 4, which is a negative value. So you can conclude here. So max, log max. That's it. Let me highlight the important part again for you. For each of the points, calculate the d. See if it's less than 0, set the point done. If you calculate, you take the value, plug into the d, you get more than 0, you have to find the fxx. If it's less than 0, log max. If it's more than 0, log min. Okay, that's it. That's all the question I would like to remind you on, hoping that it can enhance your ability in answering this question. Do take this question and keep on practicing them. And if you can get all the things here to be quite familiar with already, then maybe you need to invest some of your time into doing better in your integration. Okay. I think that's all I want to share. Any questions? Any inquiry? No? And I hope that you all can get much better in your test 2, getting above half of the total, 8 and above like that. It really will help you a lot in your continuous assessment score, providing that you are doing also you are actually submitting and doing well for your assignment. Okay, then you have a much higher survival rate to pass in the final. Okay, so for this PDF file, I will upload it in the channel. Feel free to download it. And for mathematics, practice is the key to be good. So keep on practicing if you so that you can answer the question fast enough. Sometimes you look at the solution, you understand, you really can do, but it just take a very long time to do it. It also doesn't actually help much. You feel more frustrated because you know you can answer, but you cannot answer in time. So do it, practice it frequently so that you have the speed. Okay, that's it for the today extra class. Good luck for your exam then. Take care. Bye-bye.